we'll talk about the how to approach design questions, right? Um, so if you see, one of the things that you have to know the context in which the question is asked, the intent of the question. So if so it could be a one-line problem statement like design a particular product like Oculus and so on. It could be based on your experience or your resume things. It could be role-based questions, or it could be a skill assessment question, right? So you need to know which category it falls in. So let's take the one-line product statements, right? Design on Oculus. Obviously, if you're going for a particular, so these kind of statements come if you're applied for a particular group or a target company, and you know that they are into designing those kind of products, and you can anticipate such questions may come. Obviously, the interviewer doesn't expect you to know the internal details of such a product to a large extent, but you should exhibit some awareness of, as a user, as a black box, what do you know about this product, right? So you're expected to know the product, use cases typically. As a user, if you have experienced it, or you should be able to prepare ahead if you're attending such interview opportunities. You're not expected to know the underlying hardware software platform a lot, but it helps to know. We'll talk about it for the Oculus specifically. Second is the intent of the problem statement, right? So it's not about your knowledge, it's about your, extracting your thinking process, right? So obviously, it's a single line requirement. So first thing as a designer, you would need to elaborate explore the requirements in more specific details, right? So are you able to, do that? So if that you will do by asking questions to the interviewer or making statements. So you summarize, okay, Oculus, it means it has, what is its basic functionality? It has to present the field of view, and then it has to also overlay certain contextual information. Then you will say, okay, what context means? How is the context captured? Are there going to be target markers, or markers are not going to be there? So are you going to detect those contexts based on camera image with the marked targets, or you have to do a deeper analysis to know what that context is? Like you need to have 3D scenarios. So those will have a completely different approach. So targets markers help a lot in reducing a lot of computation that otherwise we'll have to do if you're entirely dependent on a camera. You may have more than one camera, so you have to know the deployment context and so on. Basically, certain cameras for monitoring, especially more so for virtual reality than for augmented reality. So you may want to capture the 360-degree environment, or you may want to capture certain gestures. You may want to capture the gesture device from the camera and so on. So basically, you should be able to translate the general use case and the product deployment case into high-level requirements. That is the first thing that you will do. And then what you will do is basically a block diagram. So at the end of the requirement, you will put a system block diagram. So let's take an augmented reality headset. So this means it's a wearable device on the head. So what are the various blocks that you will have, software blocks or hardware blocks? Let's start with the hardware blocks. So you'll have camera. So there may be cameras. And then you will probably have a connectivity, so wireless interface, or it could be a wired connection. For example, the older Oculus Rift and all were having USB connection, whereas the Quest is wireless. Then you will have sensors. So there are different sensors that may be available on this. And then, of course, you will have a display. This is the thing which provides the visual field augmented with contextual information. And then, of course, other things. These are basically the external interfaces, and internally you may have, multiple CPU cores. It can have engines, for example, AI engine, and so on. So this you are not expected to know, but you may have to state your assumption. Are you working? You're assuming that there are engines for graphics, there may be GPUs, and so on. How do you? We'll come to that next. So basically, you start with the hardware interface, and then you draw a functional block diagram. So what is the most fundamental function in an augmented reality thing? Basically, you are going to, the final output is a composite video, right? It consists of some real video and some synthetic. It need not be video, but eventually it is presented as a video. Synthetic information. It may be an icon, or it could be text, or it could be a graphical object. So all these are, yeah.
Sorry, one basic question. Are we talking about VR headset or are we talking about AR?
AR.
Okay. So because I was wondering, why would we need cameras in the VR headset? But this is AR, right? Okay.
No, VR headsets also have cameras because you may want to sense the gestures and so on. You may have a handheld input device and so on. So if you see, some of them have wands and whatnot. So your body movements can be tracked. So the question is again, where are the cameras? VR is a little more controlled environment. AR is more open environment. So again, are you using it in public space or a private space or intimate? Basically, as this is more open environment. So the environment context is very captured by the cameras. Private space, it may be a gaming arcade or gaming room, etc. Or it could be a building and whatnot. So the VR, you have more control over the environment, and in AR, you don't have much control over the environment. So you need to take care of that. Now, so this is basically the composite video that you are generating. But in order to generate that, you may have to first do something called object identification. So your object needs to be identified like tagged objects or markers, if you are using markers. Otherwise, something called a SLAM. Basically, you are simultaneously doing the location and so it's basically unmarked targets. You are doing video analysis. Basically, this is a lot of analysis. Here, tagged objects, markers, the analysis is there. So the object identification has certain cues, like look for certain patterns in the image. So it is easy to do that. Whereas in this unmarked targets, you have to do a lot of video processing in order to do the object identification. So the whole purpose of object identification is to establish the real world context. So in augmented reality, that is what is driving what you want to augment. And the second thing is object movement tracking or object tracking. So that block you will have to think about. So if the object is stationary, or at least the object may be stationary, you are moving around. So in a relative sense, you have to track the objects, whether it's the target marked or unmarked target, right? So this is another important functionality that you will do. This you have option to do it in two ways. One is again camera based, and so it basically means video analysis. In fact, there is a term for this in the context of AI. It's called video odometry. So you look at displacement of objects and then decide, how much it has moved and therefore what context has changed. Other is sensor based. So this could be your accelerometers and gyros, orientation, and so on. So basically, tracking of objects can be one or more combination of these two. For example, this is where your design, budgeting comes in. If there is dedicated hardware for this, then ideally this can be done. But nevertheless, you may have a lot of situations where you're doing too much of computations. It may be prudent to use this for small displacements, like simple head movement, etc. And this you may want to use for only larger displacements if something has moved a lot. So these two can be used in combination. It's like in the olden days, GPS, you have assisted GPS, and then you had, you can interpolate GPS with a high accuracy or low accuracy and so on. So in fact, GPS is one of the other sensor inputs to this. So object tracking is a very, very fundamental. So object identification, object tracking is the next functional block. Then you can break it down into whether you want to do it with camera or sensors or both. And then how do you move between these two? And that means this is very important. We'll come to that next. Then you will have, of course, you will have to extract the context. The context could be like, the scenario, the 3D scenario, or a place. So you are recognizing the place, you're on the street, you're in a building, etc., or which kind of building, a mall, etc. All those kind of contexts are built. Now, where is that happening? So typically you have the AR device, and then there is a backend device, some backend, or I will say a computational device. So this is typically done here. So you have connectivity, the wireless connectivity here. So the context comes here. The input for the context goes from here, from the object tracking, recognition. Those inputs go here. So this context is probably built using a tool. So if you're developing, there are many SDKs available. So Apple has its own SDK, Google has its own SDK. Basically, the SDKs will have components here and components here. So you will be able to perform these functions. And then the game developer or the application developer will use this, will use the SDK to create whatever tagged objects, and then the logic, the logic, business logic of this thing, what changes here. And then the next part is the rendering, right? The synthesis and rendering. This is important because you have to create the composite image or video or overlaid video. So these are the main functional blocks, the object identification, object tracking, and then context extraction, and then synthesis and rendering. So you can say at the high level, these are the functionality that has been done. The next thing is, when you're designing this, you have to do the hardware software partitioning or mapping. Now, as you know, all these are video centric functions. So you will have to distinguish between control functionality and then computing functionality. Mostly these will be having dedicated engines or dedicated SOCs or cores. For example, the Oculus is driven by the Qualcomm VR2 platform. So it has, I think, AI engine. It has, of course, for rendering, one dedicated CPU. Maybe multiple GPUs for that, and so on. So there may be for basic control, there may be a SOC. So as an embedded software developer, you have to understand what are you asked to develop. Are you supposed to develop the video processing libraries or video components or graphical components, or the control software? Most likely it will be this, right? So if you have this signal pipeline, so there is object ID, tracking, context, synthesis, rendering. This is the data path, the main data path, right? Of course, there may be in the architecture, there may be shared memory for all the various hardware. So the control software is one which coordinates the various things, right? That is where you should focus on in such design questions. So because these are very specific to the platform, whereas the control functionality is more about coordination. So you need to focus on what needs to be coordinated. So you have to, one, ensure the user preferences are captured. So user preferences may be, there may be gesture related preferences, etc. It could be configured via some MMI, or it could be learned. So for example, if the user is all the time tuning the size of the field of vision, zooming, etc. So you probably want to factor that. And so this is basically to know the user preferences and then mode of operation. So whether it's passive or it's just walking or it's actively interacting, active interaction, etc. So these are the things that you will do in the coordination, and then accordingly you will program. For example, we talked about object tracking. Now, should you use so you use camera or sensor? Now, this is a control function. So for this block, so there may be object tracking block which spans camera based or camera image based and sensor based, and this may be done in two different CPUs. So you have to make sure that this algorithm is knowing that you are in this mode, you have to interpolate sensor data and then provide the object tracking. So coordination between these two cores may be required. So these are the things that you would do in the control function. The other thing, of course, you will do is the communication function, right? So again, the control of, so there may be a network offload engine. There may be a dedicated core only for the wireless interface. So how do you actually provide the data path for the network interface from the graphical or engines and so on? So this is the control CPU, control core. So you are basically taking care. So from a control CPU point of view, knowing the user preferences, then modes of operation, and then selecting algorithms like camera based versus sensor based, and then communication. These are the things that you would do on the control path. And so you should focus on the control path because that is typical embedded system design. Whereas if you're asked to design the object tracking algorithm, or that is basically a DSP special library, or an AI neural network based algorithm. So these are very specialized fields. Unless your job role is about those, and you have a domain knowledge on you need to have domain knowledge or prior experience. Don't get into that. Don't try to say you will optimize this by doing this. So you make a bold statement that you will expect that the SDK vendors and the library, so math library, for example, math library or neural network, AI libraries, various algorithms are probably available as libraries. And the SDK developers might have optimized it for a particular platform. So as an embedded developer, you should focus on the control path and stick to that, and what potential issues you will have. It's no more about the VR or AR or anything, but you will have to talk about it in the context of the VR. So you have multi-core, typical multi-core issues you will be able to talk about irrespective of the application, right? So for example, the shared memory issues, and then you will have shared interrupt systems. Interrupts, how will you handle it? And then user interface or MMI, network stack, these things, maybe your control function. These are the things that will require data at the right time. What are the data paths available, etc. So it is independent of the application. These are once you have got to this far, but you can talk about it in the context of object tracking or rendering and so on. So the approach for such questions is to exhibit basic user level. So I'll summarize. So one is user level black box knowledge, idea of the product. So you should be able to prepare for that. Then talk about typical hardware platforms. If you have read about it, like the Qualcomm XR platform and so on. Then talk about the external interfaces like the cameras. You can be, it's common sense, right? Cameras and sensors. You don't have to be specific about which sensor the Oculus has and so on. You can use your judgment to say, okay, it will have an accelerometer, gyroscope, blah, blah, blah. Then you talk about the major functional blocks. And then mapping hardware elements. Then this is most of your discussion should be on the control coordination function. Coordination, communication. So once you come to this, it becomes very easy for you to talk because it is independent of the particular product. It may have specific constraints, but that's okay. You're not designed one, so you may not know. But you should be able to talk about in a multi-core or in such a battery operated device. How are things done? What kind of control? So the MMI or some other sensor controls. You may want to talk about the coordination across modes of operation and so on, and communication. How would you do this? This becomes very easy for you to talk. So if you are aware of system design for these things, you should be able to apply it in the context of that particular product. I think this is what the interviewer would be looking for specifically. They're not expecting you to know all this, but in some level of some idea about AR functional blocks and how it can be mapped to a typical platform will be definitely a good thing to have. So basically, understand the intent of the interviewer. It's about thinking process. Are you able to break down the requirements from single line requirement to typical functional requirements and typical constraints? B, are you aware of the user level deployment scenarios, and then hardware platforms and peripherals, typical mapping, logical mapping, assumptions. Are you able to, first of all, your communication is through block diagrams, so not words. So use diagrams as much as possible for requirements, for the block diagrams for the context, and then for the data path and control path. So use diagrams and quickly get into the control path operations. So that is where it is true embedded system thing, independent of the domain. Okay.